Right, so here we have a triathlon. This is just a 20-minute section of the race. This is not all of the race. So based on the graph, during this 20-minute portion of the race, we're trying to put the bicyclists in order from slowest to fastest. So I heard some of you talking about, yeah, you need to make sure to read it carefully. Who's slowest? I think, did someone say E? D. I heard the D and I thought I heard someone say E and I was like, really? Okay. So D is the slowest. Then what? A and C are the same. A and C are the same.
Because they're parallel.
Yes, indeed, because they're parallel. And who's going fastest? B. Okay. So here, the steeper the line, the faster the cyclist is going. So Lydia wants to describe each bicyclist's rate in kilometers per minute for an article for the school newspaper. To do this, she sketches triangles like the one for line A shown on the graph at the right. Where do the 4 and the 6 come from on Racer A's triangle? Well, what we're looking at is we're looking between these 2 points. So this time is at 6 minutes. This time is at 11 minutes. Hang on, am I in the right spot? That's at 11. Oh, this is 12. That part's 10. Sorry, I thought that was 10. And then over here, this is, they've gone 11 kilometers, and here they've gone 15 kilometers. So the 4 and the 6, the 4 is the change in the distance. In kilometers. And 6 is the change in time. In minutes. So these numbers can be written as a rate in kilometers per minute to describe the distance the bicyclist rides as time passes. That is, their speed. That's what we're looking at. The fraction 4/6, and it bugs the crud out of me that they never got around to simplifying that. What does that reduce to? 2/3. Represents how the graph of the line goes up 4 for every 6 units it moves to the right. The number 4/6, which I would definitely at this point reduce, is called the slope of the line. So, use the diagram on the next page to find the slope of each of the other 3 lines. So you've got this. Find the slopes of the other 3 lines, and please reduce them. So please use the triangles that they give you to find the slopes of the other three lines. Pardon? All right, so for B, we find that this distance is 3 and this distance is 3. So the amount that it went up as it moved to the right was 3/3. The slope is 1. That person is going 1 kilometer per minute. That's 60 kilometers an hour, which is, yeah, that's pretty fast. Yeah, on a bike, let's see, every 8 kilometers is 5 miles approximately. So if you're going 60 kilometers per hour, you're going what? Oh, so you divide by 8 and then you multiply by 5. So that'd be 35 plus another 2.5. You're going 37.5 miles an hour. On a bike, that's pretty fast. Pardon? Does that sound too fast? It's pretty fast. But you're talking about you're talking about a triathlon here, and you're probably talking about some fairly elite athletes. So, all right, let's look at these other ones. So for this one, we've moved up 2 as we've moved to the right 4. So this slope starts off as 2/4, but we should really reduce it to, yeah, they're going 0.5 kilometer per minute. They're going half as fast as this other person is. And then this one, let's see, that's 1, 2, and 1, 2, 3. So the slope for that should be 2/3, which makes sense because A and C are parallel to each other. They need to have the same slope. If they have different slopes, they're eventually going to cross one another someplace. All right. So did the slopes in part C confirm your ranking? Well, what's the biggest slope? 1. Was that our fastest? Yes. And our slowest was D, and they have the least slope. So, yeah, it does match up with there. Let's move on to page 3. So this is a simple mistake that sometimes gets made. While comparing the rates from problem 1, a study team is struggling to decide how to tell which athlete is moving faster. Leo thinks that because A's line is higher on the graph that he's traveling faster. car disagrees, he starts first, but racer B is moving faster. So who do you agree with here? With who? Yeah. Kara, however it is that she pronounces her name. Because that line has the greater slope. Which represents the distance in kilometers per minute. All right, so let's look back at some stuff that we did a long time ago from chapter 4 in book 3. Here's a tile pattern. You examined how the growth rate could be seen in tables, graphs, and a rule. One of the patterns is shown, and its graph is also shown. So what's the growth rate for this pattern? How much is this growing by each time? 4. Because there are 4 new tiles for each figure. Or maybe I should say 4 additional tiles. What's the slope of the line? Well, let's see. Let's make a little triangle. So this is 4 and this is 1. The slope is 4 because it's 4 over 1. Remember, the slope is going to be how much our graph is moving up as it moves over. So for part C, they're the same. So we've been waiting this long to actually talk about slope. Slope and growth rate, same thing. So I'm going to give you a couple of minutes to do number 4 on your own. Go ahead and read that and figure it out. And then justify your answer. So when you justify your answer, that's write a sentence or 2. They need to be sentences, not caveman speak.
In 2 minutes, he has 7. Bro, how did they?
Oh, what do you mean? Let's eat.
Oh no.
The one who smelt it dealt it.
It wasn't me, bro. It wasn't me.
Bro, it was you.
No, it wasn't me. It wasn't me.
You would be laughing.
I think it was
You
John.
would- you would-
No, it's because I was smelling it. Johnny or Paul. I don't think it was.
How? No, we don't even.
No,
bro,
sorry,
I don't.
John.
I actually no. I actually don't smell
Oh,
it.
it's-
It's
it
one
was
of
not
y'all.
me.
It's one of y'all.
It wasn't me. Ben had the least reaction to it.
Ben.
Maybe he's the least childish.
That was bad. I smelled it like 5 seconds after you said it.
All right. So, who has the most hiccups per minute? Student 1, because student 1 has 4 hiccups per minute as compared to student 3 that only had 3.8 hiccups per minute, and student 2 which had 3.5 hiccups per minute. So, the slope is the same thing as the number of hiccups per minute, right?
Yeah.
So it tells you which one is hiccuping the most. So if you graphed a line for the student who hiccups 4 times per minute, would the line be steeper, less steep, or the same steepness as the line for 2? So if you graphed this one, would it be steeper or less steep or the same as this one? It'd be steeper, right? The steeper the line, the greater the slope. All right, questions? All right, then please go ahead and get started on your assignment.